In this tutorial, we will use the second derivative test to classify critical points. Find the critical points of f of x equals x squared e to the x and use the second derivative test to classify each as either a relative minimum or a relative maximum when it applies. So let's recall the second derivative test. Suppose x equals c is a critical point of f such that f prime of c equals 0. Assume that f double prime of c, the second derivative evaluated at c, exists. If f double prime of c is positive, then f has a relative min at x equals c. If f double prime of c is negative, then f has a relative max at x equals c. If f double prime of c equals 0, then the test gives us no information. So first we want to find the critical points. We do this by taking the first derivative, setting it equal to 0, and solving for x. So we have to use the product rule here, and I'll leave it to you to verify that f prime of x equals 2x e to the x plus x squared e to the x. We'll set this equal to 0 and solve for x. In the first and second term, I have an x and an e to the x common, so I'll pull those out. That leaves me with 2 in the first term plus x in the second term. Now we have a product of 3 factors that equals 0. So at least one of these must equal 0. The first equals 0 when x equals 0. The second, e to the x, never equals 0. Remember that the graph of e to the x never crosses the x-axis. 2 plus x equals 0 when x equals negative 2. This gives us a second critical point. Now that we have both critical points, let's compute the second derivative of f of x. F double prime of x equals e to the x times 2x plus x squared plus e to the x times 2 plus 2x. And I'll leave that to you to verify. Then f double prime of 0 equals 2. This is positive, which means that x equals 0 is a relative min. F double prime of negative 2 is approximately equal to negative 0.271. Since this is negative, that means that x equals negative 2 is a relative max.